So very delighted to be joined here today with Cheryl, who's a senior director here at Arm, leading our ecosystem strategy, driving adoption across cloud, 5G, and networking fields. And yeah, she'll be talking about multi-arch support today. So yeah, Cheryl, without further ado, take it away.
All right. Thank you so much, Josh. And hi, everyone. It's really nice to be here. Thank you for joining today. So my name is Cheryl, and as Josh said, I'm a senior director at Arm, and I have some slides that I'm going to talk through today. So okay, let's see if we can get these slides going. Okay, fantastic. So multi-arch cloud infrastructure from the ground up. We're going to talk about why you should consider it and some ways to get started. So this presentation is going to be targeted at mostly sort of senior technical people. So architects, engineering managers, DevOps engineers, and platform engineers, and some application engineers as well. We're going to look at what is multi-arch cloud infrastructure, why are people moving towards it, and look at some use cases and benchmarks that we've done for web servers, NoSQL data stores, and machine learning. We're going to look at some real-life experiences from Fusion, Auth, and Honeycomb, and hear about the challenges they faced, how they got through them, and what the results were they saw of migrating from x86 to ARM. And then I'm going to give you some hints and tricks for how to get started. So we'll look at a 3-step approach towards a smooth migration towards multi-arch, and then just look at some example deployments briefly. We'll look at deploying a basic WordPress and MySQL on AKS, on Azure Kubernetes service, and we will look at using GitHub Actions with ARM-based burstable VMs on Azure. A little bit about me. As I said, I am Senior Director of Ecosystem at Arm in the infrastructure line of business. So that is cloud, telco, and networking. And my mission is to get Arm to cross the chasm. So crossing the chasm is this term from probably 15, 20 years ago now, this book called Crossing the Chasm, which is all about early technology adoption. So in this crossing the chasm terminology, you have the early markets, you have the innovators and the early adopters, and then you have the mainstream market, who are the early and late majority. And between the two of them, you have a big chasm. This is usually where a lot of new technology fails to get adopted, because the early market segment, companies and individuals are usually willing to put a lot of work in to make changes. But if you want to hit the mainstream markets, then you need to go from just having these minimum feature sets to a whole product solution. So you need to make it easy and convenient to adopt, and you need mass adoption and mass support. So my mission, as I said, is to get Arm across this chasm, to go from where we are in cloud today, which is pretty early market, towards this whole mainstream market. So I and my team work on a bunch of different things. So we work on software support, including open source. We work on making sure the hardware is easily available, widely available. We work with various standards bodies, different foundations, and make sure that Arm and Arm's users are appropriately represented. And we do developer outreach. So things like this, where we talk directly to developers and tell them what is the latest and greatest. Previously, I was an engineer and an engineering manager at Google and Apple. I was a VP at the Cloud Native Computing Foundation. I've also been very involved with community for a long time. So I run a meetup with over 7,000 members, which is around cloud native infrastructure and technologies in London. So let's get into multi-arch cloud infrastructure. And let's look at some context. So cloud spending and energy usage are both under pressure. On the left-hand side, this chart shows you the growth in revenue between cloud and traditional data centers. And as you can see, cloud is not only growing, but it's still projected to keep growing for the next few years, whereas traditional data centers have kind of flatlined, more or less. So companies who are moving to cloud or using more cloud need to make sure they're using those resources efficiently, because the spending is continuing to go up, and what we call maximize price performance. So for the amount of money for each dollar that you're spending, you want to get the maximum performance back out of it. And then this chart on the right-hand side shows the internet traffic and the data center energy usage compared to 2010. So starting from 2010, you can see internet traffic has gone up 17 times, but data center energy usage has only gone up 0.1 or 10% during that time. And that's really, really important. Cloud providers and companies have put in a lot of work to make sure that the energy usage doesn't follow this top line, but instead it stays mostly flat. And in fact, there's now a EU goal of climate neutral data centers by 2030. This internet traffic is probably going to continue to go up and up and up. There's ever more streaming, ever more things like cryptocurrency, machine learning, very compute intensive workloads. And while the hyperscalers have put in a lot of work to in terms of better software and better hardware and better cooling technologies and so on, we need to all find ways to make sure that we are using this energy as efficiently as we can, as wisely as we can. So into multi-arch infrastructure. So computer architectures are either RISC, which means reduced instruction set computers, or CISC, which is the complex instruction set computers. ARM's RISC architecture targets power efficiency and performance, and you can license it for many use cases. So for many years, ARM chips have been widely available in mobile devices, because when you have a mobile phone, you want to maximize the battery in your mobile phone. It's also starting to come up in automotive, Internet of Things, and cloud now, because of those data center energy usage we just saw. That power efficiency and performance is becoming really important for the large cloud providers. The goal of multi-arch infrastructure is to run workloads on the best hardware for their price performance needs, without developers needing to be concerned with the underlying architecture. So whether it needs to runs best on RISC or CISC-based architectures shouldn't matter to the developers. All they need to know is it will run on the best hardware for the price performance needs. What kinds of workloads can benefit from a multi-arch approach? I've taken these from the ARM Community Infrastructure Solutions blog, where we look at different workloads and try and benchmark them as fairly as possible. Benchmarking is a little bit of an art, but we'll take on the same cloud provider x86 versus ARM instances. We'll use industry standard benchmarks, and we'll use vanilla installations of open source software to test on. So for web servers, we looked at Nginx performance and found you can improve the performance by up to 32%. For distributed memory cache, we looked at memcached and found a performance improvement of up to 41%. And then really impressively, on machine learning, we found you could increase the performance by 1.8 times, 80% better for deep learning inference workloads. And there are many, many, many more examples on this solutions blog, so I highly recommend you go and check them out. But generally, performance and price go hand in hand, right? if you get better performance out of something, you can pay less for it. That's what it boils down to. And in general, what kinds of workloads can benefit from multi-arch? There's broad support now for ARM across almost all of the top used open source projects. ARM-based instances are available on every major public cloud provider. So AWS, Azure, Google Cloud, Oracle, also a lot of the Chinese ones, so Baidu Cloud, Alibaba Cloud, Tencent Cloud, JD Cloud. And the team's put in a lot of work to make it really, really easy to recompile your software for ARM, sometimes with a few tweaks needed, but on the whole, we want to make it as easy as possible for you. So we're going to look at 2 real-life case studies, one from FusionAuth and one from Honeycomb, and we'll look at their experiences, what challenges they faced, and what results they saw. So the first one, FusionAuth, is a developer-focused API-first auth provider deployable anywhere. This is a sort of smallish startup, and pretty early on in 2020, one of their community members just reached out on the forums and said, hey, I'm looking at running FusionAuth on a Raspberry Pi, because he was a Raspberry Pi enthusiast. So that's the first time they considered running FusionAuth on ARM. About a year later, after Graviton, AWS Graviton came out, they started load testing. 6 months after that, it was officially supported on the downloadable version of FusionAuth, and it was rolled out to the SaaS platform in June. And within a year, more than 70% of those SaaS instances ran on ARM. Here's some more details about their technical timeline. So the first step that they need to do was to find the right JVM to support ARM, especially on Mac, because they were using Macs. And they found that Java 17 was the correct one for them to do. So they took 3 months to add Java 17 and ARM support into the code base. Then they had to update and test the install scripts and update Docker to support these multi-arch builds. Back in 2021, ARM support was not available in every public cloud region, so they had to make sure that ARM support was there for the SaaS regions they were using, for the regions they were using for their SaaS instances. And then last but not least, they updated the application to actually use the correct ARM architecture. In terms of performance testing, they knew that their logins were particularly CPU intensive because they had to do password hashing. So the team load tested 50,000 logins. They found ARM handled between 26 and 49% more logins per second and cost 8 to 10% less than Intel on EC2. And here's some quotes from the CTO, from the team and the user. So the CTO said, because we run on Java, our lift was pretty small. We just had to find a JVM built for ARM and then work out any remaining kinks. This is a quote from the user. He said, I just switched a FusionAuth instance to ARM64, and the transition was so smooth, I couldn't even tell whether it's actually running the ARM64 version. So very smooth, very straightforward on both sides. For the second case study, we're going to look at honeycomb.io. So Honeycomb provides full stack observability, enabling engineers to deeply understand and debug their production software. So they started experimenting with Graviton 2 in March 2020. About 1 year later than that, their first workloads were in production. Those were the ingest workers. 6 months after that, pretty much all of their workloads and environments were on ARM, and 92% of vCPUs were on ARM. And then another 6 months after that, they turned off the last of the x86 EC2 instances, and now they run 99% of their workloads on ARM on Lambda. So let's look at the technical timeline from Honeycomb. So Honeycomb chose to migrate those ingest workers first because they were stateless, they're performance critical, and they scale out horizontally. They were also written in Golang, so compiling for ARM was pretty easy. They were just deployed in the dog food environment. and saw positive results. Initially, the Honeycomb didn't use Kubernetes or container orchestration at all. Now they do, but everything at the time was in Terraform and Chef, so they could just switch to the ARM AMIs very easily. The next up were their own workloads, which were the easiest to recompile and they spent the most on, and Kafka. And then the last were these ad hoc one-off services and those that were difficult to migrate. So after a year of work, said they turned off the last x86 instance and moved almost entirely to AWS Lambda on ARM. And what they found was they've saved 40% of their EC2 instance bill from doing this migration over the course of a year. Again, here's some quotes from them. So, Graviton has enabled Honeycomb to scale up our compute without increased operational toil, spend less on compute, and have a smaller environmental footprint. And then Liz, who was one of the engineers who was working on it, said, I personally approached it as an idle experiment with a few spare afternoons and was surprised at how compelling the results were. Saving 40% on the EC2 instance bill for this service is well worth the investment. So, hopefully you've seen that there are some really good results coming out of these migrations for ARM. And in fact, the chief evangelist at AWS has said publicly that 48 of the top 50 Amazon EC2 customers also use AWS Graviton processors for their workloads. So in many ways, this is not an early majority thing anymore, early adopter. Actually, the early majority have already started moving over and started using ARM in the cloud very, very successfully. So hopefully that gets you interested. And now you want to know, where do you get started? So there is a lot to consider in a modern cloud native infrastructure. So here are just some of the things that you might need to look at. So you might need to consider, do you properly use infrastructure as code? Do you have your CI/CD pipelines and reproducible builds? What about packaging, the binaries, the images, the registries? When you actually get ready to test it and roll it out, so testing, scheduling, rollout, performance testing. And then when you need to upgrade your infrastructure, how is that going to work? And this diagram shows what you might consider a modern cloud native infrastructure. So Kubernetes at the bottom, a bunch of different microservices who each have their own different responsibilities, backed by different data stores. At the top, you serve it through Nginx. You manage all these microservices with something like Envoy. You also have a test environment, so you have CI/CD with various tools, and maybe GitOps tools, and then you need to monitor, so you have various monitoring tools running as well. So there is a lot going on. So the question is, where should you get started? There's 3 major steps that you can consider when you're migrating towards a multi-arch infrastructure. So I've called these ones inform, optimize, and operate. So we'll start with inform. So inform means, do you understand your software stack really well? So you need to make an inventory of everything that you are running: the operating system, container images, libraries, frameworks, runtimes, any tools that you use to build, deploy, test, any tools that you use to monitor and manage. And then you should identify the hotspots. So what are the workloads that are costing you the most money? And check each of those for ARM support. Slight distinction here. So GCC calls this AArch64, Linux kernel calls this ARM64. So from that first step, you should now feel like you know which are the first workloads to take on. Secondly, it's called optimize. So you need to provision a test environment that's based on ARM64. upgrade each of those container images and test, make sure that it's working as intended. Do some performance testing as well. Make sure that you are hopefully getting a better performance out of it. For example, there might be various flags that you might need to change between x86 and ARM versions, or you might need to add if statements, depending on what architecture you're running on. And then if you are running Kubernetes, then you need to think about how you're going to change your Kubernetes cluster. So for example, are you going to have the control plane or the work plane nodes on x86 control plane on x86, worker nodes on ARM, or are you going to have the other way around? Are you going to have a mix of them? Each of those have different pros and cons. You probably have some scripts about how you create a cluster that need updating. And then you may have some daemon sets, so things that run on every node, and you need to make sure that those are selecting the correct architecture, the correct applications for that architecture. And then lastly, the operate. So update the CI/CD, make sure that your ARM64 builds are reproducible. And then you can start deploying them using a canary or a blue-green deployment approach. So in terms of controlling how your applications roll out, then different approaches you might need to take include node affinity, taints, and tolerations. And then lastly, your different architectures might have different limits and requests on them. So you'll become aware of those through monitoring and how you have to change those. So very, very, very broadly, this is the approach that I would suggest to you. So inform, understand what your software stack looks like, optimize, take each image at a time and provision them into a test environment, and update your cluster, and then do the actual rollout and just monitor the results. So we're going to look at a couple of really, really simple deployments here, because it's very difficult to give definitive advice because everybody runs infrastructure in quite different ways. So I'm just going to look at some very, very simple, straightforward deployments and see what are the kind of changes that you might need to make. So the first deployment here is going to be deploying WordPress on top of Kubernetes, WordPress with MySQL, and we're going to deploy it on ARM-based instances to AKS, Azure Kubernetes Service. So the way to do this is assuming that you're using Terraform to create your clusters, you use a different kind of VM. You set this VM size to deploy ARM-based VMs. And then we have some scripts for you, which just are slight variations of the basic WordPress MySQL scripts. And you just run those against the Kubernetes cluster. And that's basically it. So as long as the cluster is set up to run on top of ARM-based VMs, then it should be very straightforward. You can run Kubernetes, WordPress, and WordPress MySQL on top of those ARM-based VMs without too many changes, basically with just this one. And we're going to look at a second simple deployment. This one's really hot off the press. So this one is if you're looking to save some resources, save some spending on CI/CD, because in general CI/CD is very bursty. You know, it might sit idle for a long time, and then you have a little spike where you actually use those resources, and then it will sit idle. So obviously you're spending money even if it's idle. But a different way to approach this is to use burstable VMs. And those burstable VMs will accrue credits over time that it's not being used. And then when you actually need to use them, you can use up those credits. So it saves a little bit of money. And then these are also integrated really nicely with GitHub Actions. So you can just, when you create your instance, you can create it as a ARM64 architecture, and you can choose the correct size that you want. And when you create your GitHub runner, again, you just choose your ARM64 architecture here. And then you sit back and you look at some dashboards, and hopefully you see that you have some CPU credits because you're not using your CI/CD. And then when you actually commit something to the CI/CD pipeline, you're going to see a little burst where you actually consume those saved credits. So that's quite nice. And let's go to the summary. So cloud spending and energy usage are under pressure. So companies need to maximize their price performance and use the spend and the energy as efficiently as they can. The goal of multi-arch infrastructure is to run workloads on the best hardware for your price performance needs without the developers having to be concerned with the underlying architecture. The real life case studies show somewhere between 25 and 40% in savings, 20 to 60% performance increase compared to x86. Of course, this can vary very wildly depending on your setup and your workload, but there is lots of evidence for this kind of level of savings. ARM-based instances are available on all major public cloud providers, and ARM's widely supported across the software ecosystem, both open source and commercially. If you want to get started, then think about this inform, optimize, and operate model. So find your hotspots and then manage those transitions smoothly and monitor the changes that you're making. And then lastly, you can go and look at other examples from the ARM Community Infrastructure Solutions blog for tips and tricks, other widely used open source projects, and hopefully you find some inspiration there. And that is it from me. Thank you so much. Thank you for listening. Hopefully we'll be around to answer any questions.